There is a fuel being sold at gas stations right now in 31 states that is federally illegal to put in your lawnmower. The pump looks identical to the one next to it. The price is almost the same. And if you grab the wrong one even once, your engine may already be showing damage you cannot see from the outside. I'm going to show you how to tell the difference, how to check if yours is already affected, and exactly how to fix it if it is. Start with the carburetor. On a walk-behind mower, the carburetor float bowl is typically a small aluminum or zinc casting sitting at the base of the carb body. It holds about a tablespoon of fuel at any given time. Inside that bowl is a float, a needle valve, and a series of precision-drilled jets measured in thousandths of an inch. The entire assembly was designed around fuel containing no more than 10% ethanol. Ethanol is hygroscopic. It pulls moisture out of the air. When fuel sits in that float bowl between mowing sessions, which on a residential mower might be 5 to 7 days or 3 months over winter, the ethanol absorbs atmospheric humidity. At a certain water concentration, the ethanol and water separate from the gasoline and drop to the bottom of the bowl as a distinct layer. That layer sits directly against the aluminum casting and the zinc fittings. Aluminum and zinc corrode in the presence of ethanol and water. The corrosion is visible as a white or gray powdery residue inside the bowl. Those particles travel through the jets. A jet that was drilled to 32 thousandths of an inch does not tolerate even a trace of particulate. Here is where E15 compounds the problem. E15 has higher oxygen content than E10, which leans out the fuel mixture beyond what a fixed jet carburetor can correct. Most residential walk-behind mowers use fixed jet carburetors and cannot compensate for changes in fuel oxygen content the way a modern automotive engine can. What they have is a brass jet that was sized at the factory for a specific fuel. When the oxygen content of that fuel increases, the air-fuel ratio goes lean. A lean mixture burns hotter. Exhaust gas temperatures climb. Piston crown temperatures climb. On a small air-cooled engine that is already running at the thermal edge of its design, that additional heat is not a warning, it is a countdown. Mercury Marine conducted testing on marine engines using E15 under contract to the U.S. Department of Energy. The study found signs of higher exhaust in piston temperatures and documented component failures, including a connecting rod bearing failure in one two-stroke outboard. The study was limited in sample size, and the researchers noted the results were not statistically significant, but the directional risk to any small engine running on fuel it was not designed for is real. The displacement is different between a marine engine and a mower. The underlying physics, lean mixture, elevated temperatures, accelerated wear, apply to both. Now check yours. Pull the fuel cap and look at the inside of the filler neck with a flashlight. If you see a brown or tan varnish coating on the neck walls, ethanol damage has already started in your tank. That varnish is the residue left when ethanol blended fuel evaporates. It is not structurally dangerous at that stage, but it tells you the fuel system has been running on blended fuel and sitting between uses. Now, trace the fuel line from the tank to the carburetor. On most walk-behind mowers, it is a short rubber or reinforced plastic line, usually black, clamped at both ends. Squeeze it between your fingers. A healthy fuel line is firm and slightly flexible. A line that has been degraded by ethanol exposure is either gummy and soft. It will deform under finger pressure and not spring back, or it is hard and brittle with surface cracking. Either condition means the line is past serviceable. A gummy line is already shedding polymer particles into your fuel stream. A cracked line is a fire hazard at the clamp points. Remove the air filter and pull the throttle to full. Look down the carburetor throat. You are looking for a gray or white film on the throttle plate or the venturi walls. That is phase-separated ethanol residue deposited during storage. If you see it, the jets are likely partially blocked. The engine will start, but surge at idle, stumble at full throttle, or stall under load. Here is your decision point. If the mower starts and runs, but surges or hunts at idle, the carburetor is partially blocked. That is recoverable. If the mower cranks but will not start or dies immediately after starting, the main jet is fully blocked, or the needle valve has stuck closed from corrosion. That is a carburetor rebuild or replacement job. The rebuild comes first. A carburetor repair kit for a Briggs & Stratton single-cylinder engine, the kind on the majority of residential walk-behind mowers, typically includes gaskets, a needle valve, and a seat. Jets may be sold separately depending on your carburetor model. Check your exact engine model number before ordering parts. You do not need a shop manual to do this. You need a flat blade screwdriver, a Phillips driver, a set of small socket wrenches, a can of carburetor cleaner, and a can of compressed air. Step 1. Shut the fuel valve at the base of the tank, or clamp the fuel line with a pair of vice grip pliers. You do not want fuel draining onto the engine while you work. Step 2. Disconnect the fuel line from the carburetor inlet. Have a rag ready. There will be residual fuel in the line. Step 3. Remove the air filter housing. On most Briggs engines, this is 2 bolts or a single wing nut. Set it aside. Step 4. Disconnect the throttle linkage and choke linkage from the carburetor body. These are small wire clips or rods. Photograph them before you disconnect anything. The linkage arrangement looks simple and is simple, but if you reassemble it wrong, the throttle will not open fully and you will chase that problem for an hour. Step 5. Remove the 2 bolts or studs holding the carburetor to the intake manifold. The carburetor will slide straight off. Between the carb and the intake, there is a paper gasket. If it tears or sticks, replace it. A Briggs intake gasket is $2. Step 6. With the carburetor on a clean rag on the workbench, remove the float bowl bolt at the very bottom. The bowl will drop off. The float and needle are attached to the bowl or to the carb body depending on the model. Note the orientation before removing anything. Step 7. Hold the main jet up to a light source. You are looking for a clear, round hole dead center. If the hole is obstructed or off-center from deposits, it needs cleaning. Do not use a wire or drill bit. Spray carburetor cleaner through the jet and follow with compressed air. Repeat until the hole is clear. Step 8. Inspect the needle valve tip. It should be smooth rubber with no flat spots or grooves. A grooved needle valve will not seal the float bowl properly. Fuel will flood the engine. Replace it with the new one from your rebuild kit. Step 9. Install the new gaskets from the rebuild kit. Do not reuse the old ones. The old gaskets are already swollen or compressed from ethanol exposure. They will not seal. Step 10. Reassemble in reverse order. Torque the float bowl bolt to snug, not over-torqued. Brass and aluminum strip easily. Before you reinstall the carburetor, replace the fuel line. Use OEM specified fuel line or ethanol-compatible small engine fuel line rated for your fuel type. Tygon F4040A is one commonly available option formulated for ethanol blended fuels. It is translucent yellow, which lets you visually confirm fuel flow. You will use less than 1 foot. When you reconnect everything, use a new fuel line clamp as well. The old clamp may have a corrosion groove at the contact point from the previous line. A fresh clamp is 50 cents. Use it. Now talk about fuel going forward. This is where the problem either repeats itself or stops. Ethanol-free gasoline, sold as E0, recreational fuel, or marine fuel, is the cleanest option for any small carbureted engine. Find it at marinas, farm supply stores, and a growing number of hardware chains. It is more expensive than pump gas by roughly $1 to $2 per gallon. If you use 5 to 10 gallons of fuel per mowing season, the seasonal premium for running E0 instead of E10 is roughly $5 to $20. A mower that lasts 20 years isn't built different, it's maintained different. As someone with over 20 years of experience working with small engines, this changes how I tell people to maintain them. The new Make It Last maintenance protocol shows you an easy-to-follow, step-by-step guide with over 100 pages of information about what actually kills these mowers and how to stop it. What's worth fixing? Which parts to buy? Walk hard or riding? There's one for both. Scan the QR code or tap the link up top. Make it last. That is the entire annual cost of eliminating the ethanol variable from your fuel system. Contrast that with a carburetor replacement. A replacement carb for a Briggs & Stratton 500 to 600 series engine, the most common residential engine, runs $80 to $150 for an OEM unit. An aftermarket unit runs $30 to $60. Labor at a small engine shop is typically $60 to $90 per hour. Total carburetor replacement with labor, $120 to $240. That is the cost of using the wrong fuel for 2 or 3 seasons. If E0 is not available at a convenient location, use E10 and add a fuel stabilizer formulated for ethanol blended fuel at every fill. Do not use a generic stabilizer. Use one that explicitly states ethanol treatment on the label. STA Bill 360 protection, Star-Tron enzyme fuel treatment, or PRIG. These products work by slowing the oxidation and degradation of ethanol blended fuel during storage. They do not neutralize the oxygen content increase of E15. They do not make E15 safe for a small engine. They extend the usable life of E10 during seasonal storage. If you have been running E10 with stabilizer and the engine is healthy, your interval for carburetor inspection is every 2 years. Pull the bowl, look at the jets, replace the needle valve gasket. 30 minutes, $12 in parts. That is your entire maintenance cost over 2 years of running on correctly formulated fuel. If you cannot confirm what blend is currently in your tank, maybe you inherited the mower, bought it used, or cannot remember the last fill, drain the tank before the next use. A hand pump or turkey baster pulls fuel out of the tank filler neck quickly. Dispose of the old fuel at a recycling center or municipal hazardous waste facility. Do not dump it on the ground. Refill with E0 or confirmed E10. For winter storage, drain the fuel system completely or fill it with fresh E0 and a full dose of stabilizer. Running the engine dry at the end of the season is the cleaner option. With the fuel valve closed, run the engine at low throttle until it starves and stops. This clears the carburetor float bowl entirely. No fuel sitting in the bowl means no phase separation over a 4-month storage period. No phase separation means no corrosion on the jets and needle valve. You come back in spring, add fresh fuel, and the engine starts. Chainsaws and string trimmers have smaller carburetors and more sensitive diaphragm-style fuel systems. The diaphragm carburetor on a steel or Husqvarna trimmer uses a thin rubber membrane to pump fuel. Ethanol causes that membrane to swell and harden. A swollen diaphragm does not flex properly. The engine will start cold and die when it warms up, or it will idle but bog and die under throttle load. A diaphragm kit for a common trimmer carburetor is $8 to $15. The replacement procedure is the same in principle. Disassemble, replace the membrane and check valves, reassemble with fresh gaskets. For 2-stroke engines, chainsaws, trimmers, backpack blowers, use ethanol-free fuel if at all possible. 2-stroke handheld equipment is often more sensitive to fuel quality because the fuel also carries the oil and the carburetors use small diaphragm components. Several manufacturers now offer pre-mixed ethanol-free 2-stroke fuel in cans. Steel Motomix, Husqvarna XP Premix, True Fuel. These are typically sold in quart-sized containers and retail for roughly $7 to $12 per quart. They are expensive for high volume use, but correct for occasional use equipment stored between seasons. The pump is your first line of defense. Before you put a nozzle in anything that is not your car, read the label. Federal regulations require every E15 pump to carry a misfueling warning label. The label warns against use in other vehicles, boats, or gasoline-powered equipment, and states that such use may cause damage and is prohibited by federal law. Motorcycles are also prohibited under EPA rules. That label is there. It is on the pump. The problem is not that the warning does not exist. The problem is that a quick fill, stop on a busy Saturday at a station where both pumps look the same and the labels are sun-faded and the person next to you is waiting, that is where the mistake happens. Make it a rule. If the pump has any label or identifier that says E15, unleaded 15, or contains a warning about non-road engines, use the other pump. If the other pump at the same station also says E15 and you cannot confirm an E10 option, drive to the next station or use a fuel can you filled previously with confirmed E10 or E0. Carrying a 1-gallon ethanol-free fuel can in the back of your vehicle for small equipment use is not paranoid. It is 15 minutes of preparation that eliminates a category of equipment failure entirely. The Outdoor Power Equipment Institute runs a consumer awareness campaign called Look Before You Pump. The message is exactly what it says. Briggs & Stratton, Honda, and Kohler all explicitly state in their current owner's manuals that E15 use voids the warranty and that the maximum approved fuel is E10. This is not buried in footnotes, it is on the fuel specification page of the manual. The repair that follows E15 use is not covered by the manufacturer, not covered by the retailer, and not covered by the station that sold you the fuel. You own that repair entirely. The economics are straightforward. A new walk-behind mower costs $250 to $600. A carburetor failure in year 3 or 4 of ownership costs $100 to $240 to repair. A full engine failure, which is possible if the lean condition runs long enough to cook a piston or damage bearings, makes the repair economically irrational. At that point, the mower is worth less than the repair. You buy a new one, which starts the same cycle again unless the fuel problem is solved. Older mowers can last decades with proper maintenance, but fuel storage practices and carburetor cleanliness are major factors regardless of the era. The replacement cycle shortened because the fuel changed and the manufacturing margins tightened simultaneously. Solving the fuel problem does not reverse the manufacturing trend, but it removes the primary accelerant of premature failure. Every spec, fuel compatibility reference, carburetor rebuild sequence, and fuel additive recommendation from this video is compiled in the complete field reference linked in the description. The pump looks the same. The fuel does not behave the same. Read the label, use the right fuel, rebuild the carburetor if the damage is already done, and keep the equipment you own running instead of replacing it every 5 years because of a decision made at a gas station in under 30 seconds. That is the fix.